Okay. Just want to make sure it's recording. Yes. So I'm going to continue with the lecture last time. So I was talking about all the different terminology that's used. So we have attributes for columns and tuple or rows for rows. And then one of the things I did want to mention was the null, which I didn't get time in the last class. So the null value is a bit different. So for example, if so you want to list the students, say with GPA greater than 3.5, less than equal to 3.5. So if you have a query that wants to list students with GPA greater than 3.5, it won't list Jack. If you have a query that says list students who have GPA less than equal to 3.5, it still won't list Jack. So then you say, okay, what if I say not equal to 3.5? And even then, you're not going to see Jack. So Jack doesn't get listed in any of these cases because the null is just stating that, what it means is maybe that the value we don't know right now, we haven't entered the value. It could mean any one of those things. So null does not mean zero, because if that's the case, when you say GPA less than equal to 3.5 or not equal to 3.5, that would list it. So null is a kind of a special value. So I just want you to be aware of that right now. And we'll talk about null quite a bit when we do different queries. So with this, I'm kind of ending with that stuff that I started in the last lecture. Does anyone have any questions? Okay, so I'm going to be talking about relational algebra today. And in the textbook, it's chapter 8. It's 8.1 and 8.2. And if you have the old edition, it's going to be chapter 6, 6.1 and 6.2. So in the new edition, they actually talk about relational algebra after doing SQL, but I find that it's easier for students to understand SQL if I start with relational algebra, because it forms the basis of SQL. So you're going to find SQL a lot simpler if you start with relational algebra, because SQL is based on set theory, and that's what relational algebra is about. So the basic thing about SQL is that every table is considered to be a set. So for example, the student table that we just had, that is a set. So so every row out here is an element of the set. So if I pick this one out here, so that's one of the reasons that I said that if you have identical, if you have, two rows, if they are exactly similar, I mean, that's not possible. I mean, every row is unique, because remember in set theory, if you have, this is the same as writing 1, 2, and 3. So in a set, you don't put identical elements. So that's one of the things you have to remember, that duplicates are removed. Um, though here, I do want to say in relational algebra, duplicates are removed. MySQL, which is what you're going to be using, is a bit weird. So in MySQL, I do want to star that duplicates are not removed. So, so another thing I mentioned in the last class is that while column ordering matters, row ordering does not matter. So, and that's again because of this set theory, because if you 1, 2, 3, 4 is the same as writing 2, 4, 3, 1. So the row ordering does not matter. So all the operations in SQL, they're all really set operations. Everything is just a set operation. So I'm going to go over some of the basic set operations, just a review, very quick review of that. So let's say we have two sets, A and B. So, the standard set operations, A union B, A intersection B, so things like that. So we have A and B. So if you are talking about A union B, that's everything in both the sets. So that's union operation. If you talk about intersection, that's intersection, the things that are common in both A and B. So those are the things that pretty much everyone knows. That you also have set difference. So we have these two sets, A and B. Oh, sorry. So this is all the elements that belong to A but do not belong to B. So that is the minus operator, A minus B. And similarly, you have B minus A. Okay, so so these are some of the basic set operators, and then we have the complement of a set. So that is when you have, so if you have a universal set, and then you have the set A in here. So so the complement of A, which is written like that, is all the elements that do not belong to A. So it's everything outside of A. So that's the complement of A. So so these are all these set operators. These are all implemented in SQL. So in addition, there is also something called the cross product or Cartesian product of two sets. So that's now we're looking at if you look at all of these operators, I mean that I've done so far, what they're doing is that they are not um, I'm trying to figure out how exactly to say this. So for example, let's say that, so suppose A has the elements um, 1 and 2, and B has the elements 10 and 11. So A union B would be 1, 2, 10, 11. Okay, so but what if you wanted to do something where you kind of combine the elements of A and B? So what I'm trying to say is that instead of 1, 2, suppose you wanted to create an element um, like 1, comma 10, 2, comma 11, something like that. So you're creating a set where every row is a combination of elements of two sets. So that is called a Cartesian product. So let me just make that more clear. So it's a slightly different from all these operators out here. So we have so it's called either the cross product. So if you do A cross B, it's going to be so that is the cross product. So this is again another kind of operation that with sets that's possible. So so SQL, has all of these operators. So any questions so far? If you have any questions, please jump in or write something on chat, though I don't always look at chat. So the SQL has all of these set operators that I just showed. You have the union, the intersection, the cross product, and the minus. In addition, it has operations that work on a single table. So those are called, and there are two of them. There is the select and the project. So I will be doing examples with all of these. I just want to first write it all down. And then we have the binary operator that doesn't show up on there. It didn't show up under the union intersection. I mean, normally when you do set theory in math, you don't really hear about this one, but this is something that SQL has. It is called the join operator. And then, like I mentioned in the last class, it's closed with respect to all these operators. So given this, so this is just the basic foundation. I'm going to start doing a bunch of examples on that will help you understand that. So for in the class lectures, I'm going to be using this textbook, and I'm using the database that's given in the textbook as the motivating example. So I've put up the database on my courses. And let me just put it out here. Okay, so I'm just going to show it out here. I hope that from starting from the next lecture, if you could just take a printout of this and um, keep it along with you in the lecture, because I'm going to be using this, and it's kind of inconvenient for me to split the screen, because then I have this tiny screen in which to write down. So that's kind of hard. So I'm going to do it right now, because none of you have, obviously, most of you don't have that printout in front of you. If we were doing this in class, I would have handed it out in class. So this is the database that we are going to be using throughout this semester. So the schema, it's the employee database, and it has six tables: the employee table, the department locations, the project, works on, and dependent. So you're going to get very familiar with this database, because this is what we are going to be using. And the company database, it's populated. This is a small set, and we can use this in class. And we can use this for examples. So I have actually put up the company database, the small sample and a larger one, under lab 1. So one of the things I would like you to do this weekend is go to lab 1 and take a look at lab 1, because I'm going to be doing relational algebra before I do SQL, like I mentioned. And there is a tool that will allow you to write relational algebra queries and run them. So lab 1 provides all the instructions on how to download the relational algebra tool and how to set it up on your system on Agate. Okay, so that's the example database that I'm going to be using. Oh, sorry. So it's called the company database. And so I'm going to look at the employee table. So the first relational algebra command when you log into the relational algebra tool is if you can list the entire table. So if you want to list the entire table, the command that you use is you just write down the table name. So when you write down employee, the entire table is listed. So and it'll list all the rows. Okay, so that is the command to list an entire table. If you want to list the entire database, you just, in relational algebra, just type list and it'll list everything. If you wanted to list only some rows from the table, that's where you're going to use the select operator. The select is to select some rows. So we have So again, let's go back to this employee table. If you have the entire table, it is, let's see. let's say the entire table has 1, 2, 4 columns, and it has, so let's say it has 4 columns and 4 rows. Actually, I should make it 5 rows. Let's forget it. Let's let it be 4 rows. So when you do a sigma, what you're really doing is you're selecting a subset of the rows. So the output is going to be, so you're still going to have 4 rows, 4 columns, but you might only select a subset of these. So maybe you only selected some rows. So that is what the sigma does. It only selects some rows from the table. So for example, like if you suppose the query that you want to type is, okay, so suppose the query is that you must list employees from department 4. So if you go down to this table on the left, so the employees from department 4, so you just want to list, okay. So these are the employees from department 4. So you want to list Jennifer, Ahmed, and Alicia. So in relational algebra, this is the way you would write this query down. So sigma is the select operator. Then you write down department number. So department number, if you go to the left, is the attribute name. So you say department number is equal to 4. Actually, let me just write. This has to be written very carefully on this one. So sigma, then it's the subscript. Okay, so it's department number is equal to 4, and then it's again going back, and then you write down the name of the table. So if you give this command, sigma department number is equal to 4 employee, it'll list all the employees from department number 4. Okay, so let's do some other queries. So we have list employees with salary greater than, say, 40,000. So again, if you go back to the table on the left, we want to list. So you look at the salary column on the left, and so what we want to do is list employees who are earning more than 40,000. So we want to list. So there are 3, or actually there are 4 employees who are earning, actually more than 4, I missed these. There are John, Jennifer, Ramesh, and James, they're earning. So if you have to write down this query in relational algebra, you would write it down as sigma salary greater than 40,000, and again, employee. So the relational algebra tool that you'll be downloading, you can write it down in a similar fashion. So then let's do another query. Employees, list all employees with salary greater than 20,000 in department number 4, or list all employees with salary greater than 40,000. So the query is stating that you list either you list employees who have greater than 20,000 in department number 4, or actually I didn't say that properly, or employees who earn more than 40,000. So this one too, you can just compute it, write it down in, so this is department number is equal to 4, and then this is the OR operator, and then salary. And then you have the AND. Oh, sorry. This is the AND and the other one's OR. I messed the two up. Let me just write it down. This is the, and then the employee table. I wrote just emp, but you have to type down employee, the whole thing. So so that's the select operator. So do you understand the select operator? It selects certain rows, from a table. Okay, so that was the select. So the next one is the project. So project is to pick some columns or select some columns. So again, when we have this table, let me just, okay, so we have this table, and if you do a project operator on this, the output will look like this. So that's the project operator. So it's picking some columns. So all the rows will come out, but it's picking just a subset of the columns. So for example, if you have a query, list each employee's first name and last name. So here you just want to list the first name and the last name. So all you have to do okay, so it'll just list out the first name and the last name. So I just want to do some simple queries from here. So another one is, so list the sex and salary of employees. So it would be, Okay, so it would list out just the sex and the salary field. So if you go down here, it would be just this one and this one. So the only thing is now, if you look out here, the stable employee, it has 1, 2, 3, 4, 5, 6, 7, 8. So that's the thing. It has 8 rows, but the output for this query will only list 7 rows. Can anyone tell me why the output would only show 7 rows, not 8?
There's a duplicate.
Yes, that's right. It's female 25,000. Both Alicia and Joyce, they both earn. So we have there's a duplicate. So because of the duplicate, the output will only show 7 rows and not 8 rows. So because the duplicate is going to get removed. Um, so, and okay, so another query would be, okay, so I want you to try this out. List the department numbers. So I would like you to try this one out. List the department numbers. Okay, so this should be the answer for this. It would be, you would go to the department table and do pi of d number of department. So in this case, you should not use the employee table. So part of this is, you will get familiar with the tables, the company database. So the employee who might have, I know in this particular example, there are only 3 department numbers, 5, 4, and 1. And there are employees in all the 3 departments, but you might have a database where there is a new department that has just been formed and there are no employees in the department. So therefore, for a query like this, you should also remember which table you need to pick up. So, the output of this would just be D number, and then it would list 5, 4, and 1. Okay, so do you think you understood the project and the select operators? Okay, so then let's look at another query, a little more, where there's a little more to it than the ones that I've been doing so far. So let's look at this next query. Um, List the first name and salary of employees in department number 5. Okay, so what I'm asking for is list the first name, and so I want to list in department number 5. So first name and salary. So the output should have, the output should have 4 rows. But here I'm asking you to select and also project. So you're now going to combine, you're picking some rows and some columns out here. So the thing is how to do that. So let me write down, I'm going to write it down in 2 different ways, and I want you to look at it and tell me which one you think is correct, or both correct or both wrong. So the first one is, no. So it's a subscript, I must remember, first name, salary, sigma, DNO is equal to 5. Okay, so this is one way of writing it. I've written down, first you select the department number 5, the rows, and then you do a projection, or okay, so I've written it down in 2 ways. So which one of these do you, do you think that are both correct? Or is any one of them correct, or both wrong?
Wouldn't you lose a duplicate with the second query?
Would I not lose what in the second query?
When you select just the first name and the salary, I think
Yeah.
you lose something that's a duplicate, and then you're doing a select from that, which wouldn't work.
So what you're saying is, if I did by first name and salary, okay, so let me just do this part first. Okay, let's do what you just said. I'm just going to write down the output from here. So if I did, so let's look at this portion of it first. Because it does, that's how SQL does your queries. The order in which it does is that it first will do the one closest, and then it does the outer one. So it's going to start from this end. So here it's going to be first name and salary of employee. So it's going to list everybody from here. So you're going to have first name, salary, and then it's going to list John, Franklin, Alicia, Jennifer, Ramesh, Joyce, Ahmed, and James, and all their salaries, whatever it is, and so on. So so that's the first part of it. So it's not, so there are, you said that it would lose duplicates, but there are no duplicates in this case. It might have lost, but in this particular output, there are no duplicates.
Yeah, I was thinking about sex. That was my bad.
So, but you were, but do you still think, what else, could there be something wrong with this from here? So this is the output. So this is the first table that gets generated. And from here, now we have to find department number is equal to 5.
You don't have the department numbers?
Yeah, that's right. That's what happens, is that this is the way. So remember, see, this whole thing is, remember I said it's closed with respect to these operators. So the way this query is done by SQL is that it's first going to do this inner part. So this is the output of the inner part. It's a table, and you're going to get this output. So now when I do this second part of the query, this one out here, when I look at department number is equal to 5, there is no department number 5. So, you're going to get a mistake. If you run this query, it will give you a mistake. So this one does not work actually. So on the other hand, if you looked at the earlier query, so let's look at this particular query.
Would that one return like would it be an empty table or?
Actually, you will get an error because there won't be any
Okay.
department number is equal to 5. There is no department number in this table. So you'll get an error actually.
Okay.
Yeah, and the thing is, you can try this out because you have the tool. That's I would say the most wonderful thing about this tool is that you can actually try all this out. Before this tool was there, and this tool is relatively new. It wasn't around. It hasn't been around that long. Before this tool, when I taught relational algebra, I mean, people didn't really get it because they couldn't really try it out. So this tool is really wonderful because you can really try out. And once you understand relational algebra, SQL is so easy. It's because relational algebra in some ways is a lot harder in terms of typing all these notation. So once you move from here to SQL, you'll find it very, very easy. So let me do the other query, this output of this one. Oh, sorry, I think I'm on. So let's do this one. So again, the first thing that you're going to do is this part. Department number is equal to 5. So I'm going to have to, so I'm going to do the output for department number 5 would be, so let me just, so let's come here. One second. Okay, so department number 5, you're going to get 4 rows. So you're going to get so you're going to get all the fields in here. So D number, first name, salary, everything is going to be here. And you'll get, but you only get 4 outputs out here: John, Franklin, Ramesh, and Joyce. And it's 5, 5, 5, and 5. So it's going to select all the employees who are from department number 5. So that's the first output you're going to get. And then, so it's only 4 rows. So now from here, now if you want to do the second part of the query, which is pi first name and salary. So now from here, it'll pick up this one and it'll pick up this one. So therefore, this is the query that is correct. First name and pi of first name from the table. Okay, so did everyone kind of understand what I just did? Did you understand the query and how we work and why the second one is wrong? So whenever you get this kind of query, always remember that do the project in the end. Do select the sigma before the project. And sometimes, I mean, these are all very simple queries, but when you get complex queries, it's sometimes easy to also split them up, and your relational algebra tool will allow you to split them up. So for example, the same query, you could have done it in you could have done it in the following way and it's correct. So let me just write on or. So there's a third way of doing this query. You could have done it. So create a temporary table. So this temp is really, it creates this original table out here. So it creates that. And then what the next, in step 2, you can say, oh, sorry. So you can break up, so, and I would recommend that if when you start getting complex queries, sometimes they're a lot easier to do if you break them up. And that doesn't just go with relational algebra, that also goes with SQL. It's also easier to understand the query from a readability viewpoint. Also, it's much nicer if you would break it up. So any questions on this? Okay, so then let's look at this next query. See if you can try out this next one. So list the last name and salary of employees in Department 5 who earn more than 30,000. So can you try to do this query? I would like you to attempt it.